Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, we are going to learn about heterocyclic compounds. So what is heterocyclic compound? A heterocyclic compound is one that contains rings made up in addition to carbon and one or more heteroatoms like oxygens, nitrogen, sulfur, phosphorus. Now friends, heterocyclic compounds can be classified into aliphatic heterocycles, example oxidane, piperidine, morpholine, and aromatic heterocycles, for example pyridine, thiophene, indole. Now friends, nomenclature of heterocycle compounds. Nomenclature of heterocycles by trivial names, generic names and trade names. Phenytoin or epanotein, name of these compounds, you can see. IUPAC or systematic or chemical name. So, nomenclature of non-fused heterocycles. You have to focus on these three words: prefix, stem, suffix. I repeat, prefix, stem, suffix. These three important terms is related to nomenclature. If you understand these three terms, you can easily do nomenclature of any heterocyclic compound. So what is the meaning of prefix? It indicates the types of heteroatoms, their numbers and their positions. I will show you in tables. When two or more heteroatoms of same types are present, the prefix di-tri will be used. If the heteroatoms are different, their order of citation start with the heteroatoms as high groups in the periodic tables and as low at atomic number in that group. Thus the order of naming will be oxygen greater than sulfur, sulfur greater than selenium, selenium greater than nitrogen, nitrogen greater than phosphorus, phosphorus greater than silicon, silicon greater than boron, boron greater than mercury, and so on. Now in this table you can see for oxygens, oxa, priority 1, sulfur, thia, priority 2, selenium, selena, priority 3, nitrogen, aza, priority 4, phosphorus, phosphor, priority 5, silicon, sila, priority 6, boron, bora, priority 7, mercury, mercura, priority 8. So you know the prefix name, you know the order of priority, you know the heteroatoms. Now friends, the stem. What is the meaning of stem in heterocyclic compound? It determines the ring size from 3-member ring to 10-member rings. Ring size 3, ir from tria, 4, ring size 8 from tetra, 5, stem all, 6, stem in. Now suffix. What is the meaning of suffix? They determine the state of saturation or unsaturation, which depends upon the presence or absence of nitrogen and ring size. Now you can see ring size 3, 4, 5, 6, 7, 8, 9, 10. Stem, ir, it, all, in, if, op, on, ik. Now there is a further to classification, stem plus suffix. Nitrogen present, nitrogen absent. Nitrogen present again have to saturated or unsaturated. Nitrogen absent, saturated or unsaturated. So if you have unsaturated and nitrogen present, irene, ete, ole, ine, epene, ocene, onine, ikene. Saturated iridine, etidine, olidine. If you have absent nitrogens, then if compound is unsaturated, irene, ete, ole, in, epene, ocene, onine, isine. Saturated irene, etane, olane, ene, epene, ocane, onane, ecane. So friends, first you look at the ring size, then stem, then nitrogen containing compounds or nitrogen non-containing compound. Nitrogen is present in heterocyclic compound, nitrogen is absent in the heterocyclic compound. Further, it is saturated or unsaturated in both cases. Now, table 3 The complete saturation is indicated by prefixing per hydro, adding before the total names of the unsaturated state. B. No suffix. C. No stems. If the ring size is more than 10, use the carbocyclic monocyclic name, and the heteroatom is indicated by prefixes oxa, thick, and esa. You can see here 1 thia, 6 esa cyclodecane, 1 6 thia esa cyclodecane. Now, manner of numbering of the monocycles. You can see rule number 1. Starting from nitrogens 1, 2, 3, 4, 5, 6, 2 position NH2, 3 position cyano, so 2 amino 3 cyanoazine, 2 amino 3 cyanopyridine. Now friends, rule 2. Cycles containing more than one different heteroatoms, the numbering begins at the atom of the higher priority and proceed round the ring in order to give other heteroatoms the least possible number without regards to the substituents. Now you can see oxygen 1, 2, 3, 4, sulfur 5, 6. So 6-methyl 1,4,3 oxathiazine. You can see here oxygen getting first priority, then sulfur, then nitrogens. 5 amino 1 to 4 oxathiazines. Now nomenclature of partial saturated rings. If the number of double bonds is less than the maximum, prefix dihydrotetrahydro are added to the same name of the unsaturation state. The saturated positions are given the least number after the heteroatoms. You can see 1, 2 dihydroazines, 1, 2 dihydroazines, 1, 4 dihydroadine, and 2, 3, 5, 6 tetrahydroazines. Now friend, obligatory saturated of single position is truncated by a symbol 1H, 2H, and 3H according to the position of the saturated atoms. You can see here 2H oxine, 2H pyrene, and 2H14 thiazines, and 4H pyrene, because at 4 position there is a hydrogen. This is the unsaturation. So in case of 4, 5, 6 member ring with partial saturations contains only one double bond, the suffix will be INE. When the nitrogen present ENE and nitrogen is absent, they indicate the positions of double bonds over A symbols. You can see del square 1,3 diazolines, means there is a unsaturation point indications with them. Now you can see del square oxylines at 3, unsaturation as 3, and then you can see del square thiazolene unsaturations as 2, so imidazolines. Now friend, following are the IUPAC and trivial name of the most monocycle, pyrrole, ox, and furan, thiophene, thiazole, isothiazole. So their IUPACs name azole, oxole, thiol, 1,3 thiazoles, and 1,3 thiazoles, 1,3 and 1,2. 1,3 oxazole, oxazoles, 1,2 oxazole, isoxazoles, azolidine, pyrrolidines, oxolane, THF, and 1,3 selenozoles. Now 1,2 diazoles, pyrazoles, 1,3 diazoles, imidazoles, and this is pyrazoles, 1H azepine, and 1,3 oxazepines. Now friend, pyridine azines, pyridazine 1,3 diazines, pyrimidine 1,3 diazines, pyrazine 1,4 diazines, piperidine perhydroazines, and morpholine perhydro 1,4 oxanes. Now friend, nomenclature of fused heterocycles. Carbocycle fused with heterocyclic system, heterocycle fused with another heterocyclic system. So parent name written in the end is the name of the heterocycle ring. The fused name written at first in the name of the fused benzene called benzo. I will give you example, then it will clear to you. The side of fusion of the parent ring with the fused benzene ring is indicated by alphabetical numbering and put such letter ABC. This is the face pair between the square bracket in between the prefix and parent name. In this case, the parent ring is numbered as usual, and the side 1, 2 take letter, side 2, 3 takes letter B, and side 3, 4 takes letter C. This is the face pair. Now you can see benzo C pyridine. Why C? Because it's attached at the C face. Benzo B pyridine. Why B? Because it attached with the here ring contains one double bond is missing. So just put it. The total numbering of the complete fuse system is done to determine the position of saturation or some substitution according to the following rules. The fuse system is oriented so that the greatest number of rings is in the horizontal row and the remaining rings above the right of the horizontal row. So the numbering starts from the atoms next to the fusion, giving the heteroatoms the least possible numbering and continue numbering in clockwise directions whenever possible, and the fused carbon are given the same previous number, adding to it letters A, B, C. In case of polycycle, the parent's name is given to the largest heterocycles containing many rings, provided it has the famous trivial names. So you can see the quinoline, benzo H quinoline, so benzo C pyridazines, quinolines, or quinazolines, you can see, and benzo pyrazines, quinazolines. So benzo B quinolines, dibenzo BE pyridines or echidines. Phenothiazines, 10H dibenzo BE 1,4-thiazines, and indole benzo B pyrols. Now you can see coumarin benzo B pyrene 2,1, chromone benzo B pyrene 4,1, and benzo B indole dibenzo BD pyrol. So now friends, IUPAC rule for the naming such system also composed of 4 points. The parent name given to the more prior heterocycle is used as suffix. The fused ring name is the less prior rings and used as a prefix. The site of fusion for both rings. The numbering of the total system. There is a lot of word is not written properly, so be careful. The nitrogen containing ring must be taken as parent ring. You can see 1,4-oxathiazines, 2,3-B pyrrole. Here you can see if no nitrogen, the ring contains the more prior heteroatoms according to table is considered as parent ring. So thiino 2,3-B pyrene. Now the largest ring size is taken as parent ring if the two rings contains nitrogens or does not contain nitrogen. Pyrrolo 2,3-B pyridine, furo 2,3,2-B oxypene. Now the largest number of ring with the famous trivial name is always used as a parent name. Pyrrolo 2,3-A carbozoles. Now the ring containing the greatest number of heteroatoms or greatest varieties of heteroatom is the parent ring. Pyrido 2,3 pyrimidine, imidazo 4,5-D thiazoles. So the component ring having the more prior heteroatom according to table 1 is the parent ring. You can see selena zolo 5,4-D thiazoles. The parent ring in the ring containing a more number of carbon atom adjacent to the fusions. You can see parazino 2,3-D pyrimidine, parazino 2,3-D pyridazines. So furan, furo, thiophene, thiino, pyridine, pyrido, pyrrolo, pyrrole, pyrrolo, imidazole, imidazo, quinoline, quino. So the side of fusion with the parent ring is numbered alphabetically and the letter of fusion is placed between the square brackets as it's in. The side of fusion of the prefix ring is indicated by 2 numbers denoting the 2 positions of the fusion with the parent ring. These 2 numbers are also placed first in the square bracket and order of written these 2 numbers confirm the direction of the letter of the parent ring. So you can see thiazolo 4,5 the position of attachment through B phase pyridine. Thiazolo 4,5 the attachment to position B phase pyridine. Now give the lowest number of the more prior heteroatom according to table 1, especially when the present just after fusion. But if more prior heteroatom is not nearest to the fusion side, the other nearest heteroatom after fusion must take least possible numbering regardless of priority of table 1. So you can see 7 nitro 1,4 oxathiino 2,3-B pyridine, 7 bromo pyreno, 3,4-B pyrazoles. So friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel and thanks for watching.